Hello everyone. In this session we'll see residue theorem. It says if f of z is analytic in a simple closed curve C except at a finite number of isolated singularity within C, then the integration of f of z dz for the closed path is given as 2 pi I sum of residue at singular point within C. So what is very much important here is that the singularity should be within that region defined. Whatever residues, whatever singularities we have outside this region is not to be counted. And how to calculate this residue? It is if f of z has a simple pole that is of order 1, obviously simple pole means of order 1, then residue at, let's say, point A is given as limit, then residue is given as f of A limit z tends to A for z minus A into f of z. Also, if f of z has pole of order, let's say n, at z equal to A, then the residue f of A is given as 1 by n minus 1 factorial limit z tends to A for d by dz1 minus 1 n minus 1th derivative of the function z minus a to the power of n into f of z. That is, if we have nth order of poles at some point, what we can do is we will multiply that function with that order of the poles, that is z minus a to the power of n multiplied with f of z. Then we will take the n minus 1th derivative with respect to z. Then we will take the limit z tends to a and we can multiply it with 1 by n minus 1 factorial. Other than that, let's say for f of z taking a form of phi z by psi z, where psi z is given as z minus a times of f of z with f of a not equal to 0, then this residue at a is given as phi a divided by first derivative at a of the function psi. This won't be coming in use very frequently. The first two are of the main concern.